So let us get started. A little about myself. I am a Docker captain as well as an ARM innovator. I have been writing a blog from past like 5 to 6 years, and it is on collabnix.com. This is my personal blogging site where I write a lot about Docker, Kubernetes, Redis. There are around 250 plus blogs which I have written around Docker and Kubernetes. So definitely you can go ahead and check it out. I'm also a Docker community leader. I have been leading a Docker community as well as the Redis community together. Right now, I'm working as a developer relation manager at Redis Labs, and I worked in the past, like I worked in the companies like Dell for around 8 years, and VMware and CGI. So the thing which I'm going to talk about is, let me start with something, to give you the context, like why I'm talking about the Redis time series itself. And this is one of a kind of a robotic platform which I'm working on, which is called as the Cherrybot system. Now, Cherrybot is one of the project which I started along with one of the Python developer around like 5 to 6 months back, and it is all about AI-powered payload delivery system. It has around 4 wheels. The idea is this is the first diagram or the first thing which hit my mind when I went ahead and drew it. And the idea is building an autonomous robotic platform which is equipped with Jetson Nano as well as GPS modules, cameras, lidar sensors. And this robotic platform is going to be a kind of a Swiggy guy for you. So think of it as like how you order a food from Swiggy or Zomato today. You just order on the mobile app and the food is being delivered to you. The same thing is what this Cherrybot is going to do. The main component which I have been using for Cherrybot is a Jetson Nano, which is like an AI computer from NVIDIA. And I have been talking a lot about in a lot of meetups and conferences. But this is one device where you have a complete GPU inbuilt into it, and where you can run all those AI workloads. It comes with the GPS and swappable batteries. Right now, the swappable batteries last for around 30 to 1 hour, but that can be extensible. The beauty of this device, the prototype is more like it uses a deep learning platform to interpret all the data which it gathers from the environment. Okay, and there is a reason why we do that, because it has to detect all the objects. It has to be a fully autonomous system, right? And it can also identify the objects and people, and it can, in order to avoid the collision. If you really want to know more about it, this is my GitHub repo where you can find all this information. I am planning to update it, very soon, because I have written few of the blogs and published in collabnix.com, which is my personal blogging site. Now, the Cherrybot system, right now, if you see, the usage is going to be across the 3 different industry. One is the food industry, one is in the conferences for distributing the swags, and one is in a kind of a medical industry, like medicines, where it will be able to, think of it as like in a food delivery. Say you have a university, and within a university premises, you want to deliver food. And because that is a limited area where you can take care of it through the GPS or, the camera module. So Cherrybot is going to deliver the food provided with all the authentication and authorization, where it will authorize through your mobile phone and you can collect food. In the same way, in the conferences, when you have you want to distribute a swag, so Cherrybot is going to help you in the distributing the swag. So right now, you basically visit the booth and then collect the swags, right? So Cherrybot is going to come near to you, identify you, and based on your interest or a facial expression, it is going to deliver you the swags. In the same way, we have a medicine delivery where, say, if the nurses or doctors want to go ahead and deliver the medicines in a touchless basis. So this is the robotic platform which is going to be in use. Now, as I said, right, we started working around 5 to 6 months back, and the base or the foundation object which we the robotic platform which we choose is RoboMaster. So RoboMaster is a product from DJI because we need to have kind of a mechanism wheels. So that is the reason, and we want to start with something like how the robotic platform is going to respond to your image recognition, or the clap recognition and all those things, right? The line recognition. So it all started with a kind of a bunch of hardware. It took us some time because of the COVID reason. We can't travel abroad, but we managed to get all of these things in place, trying to teach Robert all those sort of, the vision marker recognition, clapping recognition, the line recognition, color recognition, and all this thing. And this is our setup where we started working together. We started building around it. So if you see, these are the like mechanism wheels of the robotic platform. So think of it as like if your robotic platform goes ahead and is stuck somewhere, so these mechanism wheels helps you to basically tackle the obstacle and then take a different direction itself, so that it is very easy to go ahead and control. You see all those electrical equipments here, the wheels and all this thing. It took around, like, I would say 1 or 2 days to go ahead and assemble completely. You see on just below here, you see a kind of a battery. So this battery lasts around like 30 minutes to 1 hour, but provided we are in the prototype phase, right? So we just wanted to get started with it. Now, this is how the baseline of RoboMaster is going to look like. So if you see here, one of the component is a Jetson Nano, and this is an AI computer. This is an IoT edge device. And this Jetson Nano, what we did, we basically placed on top of it. And then we have an arm here, which basically goes ahead and try to fetch the things, how to, even if say, if we are adding some kind of a food packets onto it, the containers, basically I'm talking about the robotic container where you have a kind of a space inside where you can place all those food materials. So these devices, like all of these things, will be controlled by a Jetson Nano device. And this is on the right hand side, which you see here. We need around 5-volt 4 ampere power supply, and then it comes with the GPU, and you have a Wi-Fi module on top of it, which basically through the phone you can connect to the RoboMaster and then get the packets. Now, there were a few of the challenges which we faced. One of the biggest challenge which we had is, like, when you have a food packet inside this container, there is some kind of a temperature which has to be maintained for the food so that it remains fresh. And that requires your pressure, humidity, and temperature inside the container, and that has to be maintained. And that was one of the challenge. This is the basic 3D printer model which we started looking into it and try to build very similar to it. Still, we are in a phase where we need to add a lot of things like a flap. We need to go ahead and add a lidar sensors. GPS model is in place, but one of the challenge which we were facing is finding an intelligent IoT based food monitoring sensors which can help us detect what would be the quality of the food inside it. And that is where we came across BME 680 sensors. Now, these are the sensors which basically sits right on top of your IoT device. It's a low power gas, pressure, temperature, humidity sensors, and it is being used by typically in multiple industry, right? Even if you are in indoor, you want to check the indoor air quality, you can check it. Home automation, it has been used. Internet of Things, weather forecasting. And one of the the pain point was to have those kind of a sensors equipped into your IoT device, you need to have a breadboard or something. But these sensors directly you can attach it on top of the Jetson Nano. One of the problem which I faced during the early phase is like BME 680 was not available in India last year when we started looking into it. But right now we managed to get one, and also we have one in the remote. So we have around 5 node cluster on the remote where we go ahead and test. But this is one of the sensors which directly you can insert into the Jetson, and then you can start playing around with getting all those metrics. So once you connect this, actually there is a Linux command called as IC2 detect, which basically try to scan your I2C bus, and then it basically detects whether the sensors has been loaded or not. Because the Jetson Nano runs an Ubuntu OS. It comes with a Docker pre-installed, so you don't really have to go ahead and install Docker on top of it. It also runs Kubernetes. So it is a kind of a credit card size device which allows you to run the AI-based container workload, right? All those things. Now, the thing which I am going to more interested was, like, how can I get those, because I need to measure the temperature inside the container, whether my food stuffs are fresh or not. And that is why I started looking at some kind of an architecture where, say, if I really want to build an analytics tool around it, and that is where I came up with a kind of an architecture, and I usually blogged around it early this year, where you have a sensor data where you are going to push it to the Redis time series. Your Redis time series can be running on your laptop or on your any other machine or directly on the Jetson Nano. So today you can compile a container image of Redis time series directly on the Jetson. And then the next step was, okay, we have a data. Now how I can go ahead and plot it over the Grafana. So today I am going to, in this session, I'm going to show you a kind of a step-by-step, like how I all started, how I used Redis Enterprise Cloud. You can also use, the Redis database itself. You can build a complete stack on top of Jetson Nano also. But I want to show you like how Redis database, which is running over the Redis Enterprise Cloud, which is like a free of cost, I would say till 30 MB space, you can use that. So I'm going to leverage that as our Redis server. And I'm going to run a kind of a Docker container, which basically has everything compiled in Redis plus Redis time series on top of your Jetson Nano board. And then I'm going to push it to the Grafana for a fancy dashboard. So before that, I have one slide which talks about Redis time series. Now, the Redis is a kind of a popular NoSQL database. It is key value paired database, key value based. But one of the thing is we have a support for all sort of you might have heard about data structure and all this thing. But one of the thing is Redis too. If you really are using a kind of, say, document based database. Now we have a Redis JSON, which can fulfill your needs. In the same way, we have a Redis AI. There are certain modules, around 6 to 7 modules, which you can, if you go to developer.redislabs.com, you can see like there are list of the modules. We have Redis JSON, which handles your JSON document. We have Redis AI, which has a tensor inbuilt into the Redis database itself. Your data is very closer to it. We have Redis Search, which works very similar to how the Elastic Search works right today. So the idea is you don't really have to rely on third-party tool. Everything is available in the Redis itself. And Redis time series is basically a kind of database which manages your time series data. So whatever the data which you get from sensors, those are like a timestamp data, like during the course of time, what are the readings from temperature from the sensors, irrespective to temperature, pressure, and humidity. So those are in a definite time interval, right? So Redis time series helps you to manage those time series data. It is mostly used for Internet of Things, stock prices, and telemetry. I would recommend you to go to redislabs.com/tech blog. And you can see amazing blogs written by the Redis Labs engineers on the stock prices, like how you can do a kind of a financial trading. How can you build the application based on the financial trading rightly using Redis time series, Redis gears, and all this thing. And the beauty of Redis time series is that you can query millions of samples, okay? Millions of samples and events, which is at the speed of Redis. And Redis completely works on your memory, right? So that's why it is fast. Irrespective of other relational databases which uses disk, Redis uses memory. Okay, and we do have a support for Redis on Flash, which is with the enterprise version. So if you are really worried about the hot and the cold data, all of these things, you can still use the Redis Enterprise. And you can also use Redis time series for an advanced tooling, like a down sampling and aggregation, all these things, the queries over the queries, all these things. And you want to really get more and more data around the different timestamps, you can get it. And one of the good news for DevOps engineers is if they are really working with Redis developers inside their organization, they can definitely go ahead and look at the integration. So we have an integration with the Datadog. We have an integration with the Grafana, Prometheus, and Telegraph, and all those monitoring tools, which basically helps you to monitor all those microservices or distributed system. So this is a kind of a snippet of command. since Redis is a is a key value database system, so we have a key called as TS colon carbon monoxide. This is a kind of one example of air quality monitoring system. And this is how you go ahead and create those keys. Like ts dot create is a Redis time series specific command which you can create a key value pair. And so the way how you do, you first create a new time series, you add a sample to it, and then you try to run a query on top of it. So this is one example of air quality um, sensor data where you have three different keys: carbon monoxide, relative humidity, and the temperature. And the way how you add the samples, right? You add a new sample is like shown in the second example where we have ts.add. So that is basically a command which you can run, and then you have ts.get, because get is the command, so it is very easy to understand. With add you can add the samples, and with get you can basically query it. Now when I started with this kind of an architecture, so the first thing is we need to get an hardware in place, right? And that is where your Jetson Nano 2 GB model, which is like $59, and you have even I would say if it works with 4 GB also, it's just a form factor difference. You need a 5-volt 4 ampere. So if you're thinking like if you can use your mobile adapter, it is not going to work, because mobile adapter is more like a 5-volt, but this is something like 5-volt 4 ampere. So you need to have a separate adapter. With 2 GB we have a support for Type C, so that will handle all the situations. You don't really have to worry about the power. On Jetson Nano, you have an operating system running on top of it, and that operating system is Ubuntu. Okay, and that consumes space for sure. And the whole operating system runs on your SD card, just like in your laptop or in your server. You have a hard disk or SSD drive. In Jetson, we use an SD card, and that is our hard drive. So for this demo, I used around 128 GB because I have a couple of containers which I have to run on top of it. So Grafana runs inside a container. You have a Redis time series which runs inside a container, and even the Python script which I have developed, that runs inside the container. So, and then the major part is BME 680. And coming to this is how the Jetson Nano it looks like. It has a micro SD card slot. We have an HDMI output port, and it is a full-fledged laptop kind of a stuff where you have all those ports available. And also it has a GPIO pin where you can go ahead and use it for certain kind of sensors control. Also a display unit HDMI is supported for this. To just take you through, so one of the things which I want to talk about is a BME 680. I think we have already talked about it, but this is a kind of a sensor which can help you to go ahead and monitor it. All you have to do is just insert it on the Jetson, power it on, and we are well good to go ahead and prepare the setup. Now, to prepare the setup, the first and foremost thing is you have to, if you want to run a latest version of Docker on top of Jetson Nano, you can do it. You just have to go ahead and install it. And then I have created a kind of a Docker image, which is Redis time series -Jetson. So you can pull it and you can run it. And this image is also going to work on your Raspberry Pi. So if you have a Raspberry, because this is the image which you build on a laptop is like an x86 based image, but for devices like Jetson Nano, it has to be an ARM based image. So if you try to run it on your laptop, it might or might not work. But this is an image which I created for you guys to go ahead and try it out. And also we have a Grafana. It's just a single liner command to expose it port 3000, and then you have a sensor script. So let me jump directly to one of the demo which I'm going to show you. So let me see if things are good. So this is some kind of a sensors which I have already set up. So I have just stopped it. So first and foremost thing is right now, if I have to, I hope this is visible. So I have cat etc issue. I have an Ubuntu. which is running on top of it. And this is basically I am rightly on top of the Jetson Nano board. Okay, so if you see here ARC64, it basically is a Jetson Nano board right now. And the way how it is going to be is I have a kind of a repo. Let me go ahead and look into it. Hang on. So if you go to, so let me go to the github.com/redis developers/redis datasets. Okay, and there are a couple of sample Redis datasets here, and one of the thing which of our interest is basically a real-time IoT sensor data, where you can see all those codes are available. And one of the thing which we have developed here is a kind of a Python script which basically takes all those BME 680 modules. I'm going to show you an example on this. So this is a kind of a Python script which fetches the sensor data. We can run it on inside a container, but at the same time, there is an option where I can go ahead and I will show you an example where I run it manually so that you will get to know. So let me go through this. So what initially we have certain modules which have to import. BME 680 is a module which basically allows you to fetch the data from the sensor. And there are few of the parameters which we are setting it up, say like the humidity, pressure, and temperature. So these are the three, the oversampling settings which has to be tweaked. And then we are passing all, especially the information related to the Redis. So this is where we are specifying the port and the password. So I'm going to show you Redis Enterprise Cloud because that is up and running, but I can also run it directly on top of Jetson Nano 2. And these are the keys. So since Redis time series is basically based on the key value database, right? So we have all these key which we have declared here. And then all the rest of the code is basically we are trying to execute commands like ts.add, which basically adds your time series, and ts.get, which fetches that value. Okay, so what I'm going to do here is I have already cloned this repo. So let me say Redis time series. Sorry, Redis time series. And then under the Redis time series, we have real-time sensors. And this is where the code is. Okay. And one of the things which we are going to run, so I just took it for this. So I am going to run a kind of a Python script with this, and this is my host. Now let me show you how to set up a kind of, if you go to app.redislabs.com, so let me log into it. Okay. So I'm just authenticating here. So once you log into it, I have created a kind of a database which is a time series based database. So if you go ahead and create a new database, there is an option where you can select a module. So if you see here, there is a subscription name which we don't need, but what we need is an endpoint here, the password. I can go ahead and see the password. So this is a kind of a demo which I have created, and then you have to select a Redis time series. So this is what is the endpoint of Redis Enterprise Cloud database, which I'm going to use it. And so what we are going to do, we are going to fetch the data or the sensor data from our IoT device and push it directly to the Redis Enterprise Cloud. So let us do that, and let me go ahead. So the first and foremost thing, what I'm going to do it, I wanted to show you like where are the containers which are running here. So if I go to Docker PS and authenticate myself, I can see that there are already I have run a time series Jetson, Redis time series Jetson based Docker image or Docker container, which is already running. I have also a Grafana which is up and running here. Okay, there is just a very simple command. So let me go through each one of these commands one by one. So this is how the whole demo is going to look like. The first thing is let's verify if the Docker is installed or not. So we have already verified that. And verify if the sensor is detected. So I'm going to pick this link and put it right here. So if it shows me a kind of, so if you see the 76, this is what it shows. Basically, it basically scans the I2C and then detects. So right now it detects that the sensor is detected, sensor is present. Okay. If you really want to go ahead and want to build a Docker image, so I have a steps. I'm going to share this link at the end of the session, so you can just clone the Redis time series, our official GitHub repo, and try to build it. So right, and what you need to do here is run a Docker run and time series hyphen Jetson, and it is going to it will show you whether the time series database is modules is up or not. So you can use info module command to basically see the modules. So it shows like this particular module is up and running. So this is what we did. We clone the repo, and there are few of the modules which you have to basically go ahead and use it. One is you need to use pip and then install BME 680 assemblers and the Redis. So these are like you need to use the Redis client which uses Python, and then you have a few of the modules which you have to load. And once it is done, one way is if you are running Redis locally, you can run Python 3 sensor loader 2.py, and this is and kind of a standard port which Redis runs on, so you can run on top of it. Okay, and this is let's go ahead and run it. So right now I have already used a local host like when I was deploying a few days back, but I want to use a Redis Enterprise Cloud itself because that is something which is free. So you have a choice using any of them. So let me go ahead and try to pick up this particular command which uses Python, and then at any point of time you can go ahead and do it. So once I run this command, it start fetching all those sensor data. So you see here these are the three different values. One is temperature, pressure, and the humidity. Now since we have already Grafana up and running, so let me open a Grafana dashboard here, which is right here. So you just have to run a kind of command. So the first and foremost thing what we need to do is we need to go ahead and if you go to the Grafana dashboard, there is a kind of, we have a Redis data source of Grafana which is supported. So I will select Redis here. Okay, once you select, you need to specify the values here. So this address is going to be our Redis Enterprise Cloud. Okay, because that is where we are going to plot it, right? And then we have a password. I will go ahead and save the test. It says data source is working unexpected. So now we have a three different dashboards. So if I go ahead and select Redis, it basically gives me all this information like ops, network, memory, and all this thing. So Grafana is free of cost, so you can use it at any point of time. So you see here all those different commands being executed here because these are the sensor values which are getting added. This looks fancy, but at the same time, I am more interested in plotting a kind of IoT sensors data, right? And that is where I will go ahead and add a panel here. So let me go ahead. So if you go to the data source, I will choose Redis. Now, Redis data source for Grafana supports all those the modules. So right now, if you see, we have a support for Redis Gears, Graph, Redis Search, time series. So since we are using time series, I am going to choose this command. And then what kind of a query you want to run. So we have a ts.get, and then let me add the first key, which would be temperature. I'm going to set a kind of an interval of 500 milliseconds. So you can see here the streaming interval is millisecond, and then I say run. Now, once I click on the run, the visualization I can pick up as a gauge, and you can see here the panel here, which says like the panel list here. I am going to say IoT, or I am going to say temperature. Okay, and say apply. So I have the temperature in the form of the gauge, right? Now let's add the next panel, which would be, I'm again picking up Redis time series, Redis get, and this time I'm going to pick up pressure. Okay, once I pick up the pressure, the same thing, the 500 millisecond interval, and then under the gauge. I'm going to put it like this, and here I'm going to change it as a pressure here. So I got this, and the last one is humidity. Now for the humidity, the same stuff which I'm going to do quickly, where you have ts dot humidity. I hope I spelled it correct, and then 500. So this looks good, and I'm going to choose the time series as a gauge, and this is how you will have humidity. Okay, and I place it. Now this is how basically you plot the graph over the Grafana, and this gives you an idea about how really we can do some kind of an IoT analytics. Now this is really important at the same time, because it was so easy, right? It just took around 5 minutes, less than 5 minutes to go ahead and set it up. So the idea is, you have one Python script which is running on top of your Jetson Nano, and then you are pushing that data directly over to the Redis Enterprise Cloud, which is nothing but a Redis server with time series modules which is enabled. And then after that, you are plotting it over the Grafana. So with these three different steps, and all of these things can be run inside a container. We have a Grafana running inside a container. We have a Redis time series running inside a container. And just to showcase you an example, maybe we can also create a kind of a one Docker Compose file and put everything on top of it. And this is something which I wanted to showcase it to you. And this is what we did here, right? And we collected the sensor data from our IoT device, put it in the Redis time series, which is again running on top of a Jetson, and then put it in the Grafana. Now, one of the thing, which I want to talk about is, like, this is just one example. This is how you basically plot all those temperature, and this gives you an idea. And this was really helpful for our in-house project, because we really need to look into whether our food packets are going to have a favorable temperature, pressure, and humidity inside the container, so that the food has to, because when you deliver a food, one of the first thing is it should be hot, but at the same time there are certain temperature which has to be maintained, right? So we use BME 680 for most of our cases. There are other sensors which you use, lidar sensor, which is more on trying to avoid the obstacle and try to find out whether the objects comes in front of you or not. But this was something I wanted to showcase. If you are really interested to implement it, definitely you can go to the first blog which you see in the screen, how to manage real-time IoT sensor data. And there are infinite possibilities of how you implement it with a system. And this Python script is going to, if you are picking up any new sensor or any different kind of a sensor, you just have to go ahead and load that module. That's it. You can also go to developer.redislabs.com. So this is I want to spend some time here so that it becomes easy for you to really say 5 minutes to give you an idea about what we have been doing here. So developer.redislabs.com is a site for it's a kind of a developer journey where you start from create, develop, and explore. And it basically you can go ahead, you can find the resources by the languages, you can build with the Redis modules and how to tutorials and all this thing. And even if you are really interested to say start with the time series, you can just go here and say start with the time series tutorials. Like we have each and so these are like a step by step detailed information how to go ahead. So this is basically how I set up Redis time series modules on top of Redis Cloud for my setup. So where you have to go ahead, click on. So if you see here, we have a different modules here: Redis, Bloom, JSON, Graph, and Search. And you have to just select the time series. And if you really want to start with all these examples, we have all the sample code, how you query, how do you guess the last sample, how you get the last sample matching a specific filter. All of those queries are supported today, so you can run on top of it. And even if the Redis time series is also something which which can help you in the stock prices also, right? One of the other thing where you can really get into it is, like, if you really want to learn about Redis data source for Grafana, what are the what are these features and capabilities. So with Grafana 8, we have a Redis Explorer which is coming in. So that is something which is promising. So if you really want to learn more about Redis data source or Grafana, how to set it up and how to install it using Docker Compose, Homebrew, and then all these things. So there are a bunch of stuff which is available even developer side, and this site is for the community. So feel free to go ahead, contribute for it, and hopefully if there is anything which you want to discuss, feel free to reach out to me. And these are like bunch of other the links which I was talking about. I have also one of the blog which I have which shows like how to run everything in the container, which is posted in Collabnix. So yeah, so this is what I wanted to show, and I am towards the end of the session. If there is any question, so let me look at if there is any specific question here. One of the question is okay. Okay, fine. I think this is already been answered here. After IoT data is transferred to pipeline, Microsoft will the process be persisted. Yeah, so I would like to take this question. Yeah, so definitely there are like Redis can be used also as a primary database, right? So think of it as like if you are running Redis inside a Docker container, at the same time, if you want to persist the data, so you can always go ahead and we have a certain settings in a Redis conf which allows you to go ahead and persist the data. So Redis is not just a caching; it is also used as the primary database. So you can always use that. And okay, so the other question is how much does a Jetson Nano board cost? So usually it is like the 2 GB cost around $59. So it is available in India, as well as we have a 4 GB which cost around $99. Okay. Now these two boards, even when an NVIDIA launched 2 GB around like if you look at the Raspberry Pi, the only the difference what you get is like if you are like planning to buy whether the Raspberry Pi or Jetson, I would prefer, or I would I don't work for NVIDIA, but I would suggest you to go for Jetson, because with the Jetson you get a GPU device. If you really want to use it with the Raspberry Pi, there are chances that you need to have separate equipments to make it work. But Jetson comes with GPU device where you can run all the deep streaming, object detection, analytics, all sort of things. And think of it as like whatever the robotic platform which we are trying to build, it basically uses the AI. It runs a lot of AI workload. So you can there is a kind of a Jetson, NVIDIA Jetson software stack which you can build on top of it. And so yeah, so I think that is helpful. So what is the cost of building the entire system? Yeah, I think I was expecting that kind of a question. So if you see like usually if you look at the Amazon Escort and all these things, those are like high-end devices which they use for the package delivery. They have already started the service. And then there are few of the other vendors which have been doing, especially in China as well as in US. So usually this cost around 3 to 4 lakhs rupees. But what I am planning to do is something in across like $700 to $800. So that is going to be the cost, entirely the cost. The main cost, which if you look at the equipments itself, we have a 3D printer which cost around 70 to 80,000 rupees. The Prusa one which we have been using. And then if you just talk about the hardware, we have a Jetson which cost around $99, and rest of the things like the lidar sensor which cost around 4 to 5,000 rupees. And then we have if you look, most probably even the RoboMaster cost around 500. But RoboMaster is just like for the prototype which we are going to use. The entire final product is going to be going to look a little different here. I'm expecting to build the first complete prototype by October, and then I have a presentation in the ARM Dem Summit where I'm going to, if I get a chance, I want to showcase this. But still, we have around 2 to 3 months to go trying to build, and definitely we can have one session in our meetup where we will go ahead, where I can go ahead and collaborate with the Python developer and try to see showcase that particular device. So yeah, so I don't see any further questions. So if there is any, do let us know. First of all, thank you so much for being with us. And also I would like to thank Yanis. He has been he has been very comfortable to work with. So if you think like you have a kind of very interesting Redis story to share, just reach out to me, and definitely there is a lot of room of collaboration which we can do. We are also planning to conduct these meetups every 2 months. But if there are more and more stuffs coming in and more speakers, definitely we can make it every month at least. So we are open for the feedback. Do let us know. And one of the thing which I want to say is, if you really want to get started with the Redis journey, developer.redislabs.com is a site. It is completely hosted on Docusaurus, which is a product from the Facebook, as well as it is hosted over GitHub. So if you have used the GitHub in the past, and if you are more interested to contribute, just raise a PR, and I would be happy guy to go ahead and merge it. So thank you so much for your day. It has been really great, talking about IoT shipping technology from Yanis. So we look forward to collaborate, and we'll be back soon after 2 months with another interesting chapter. So thank you, and have a great day. Okay.